Okay, this is test 3 review, part 2. And do problem 3 here. Determine if a vector is an eigenvector of a matrix and what its corresponding eigenvalue would be. And so we'll look at each of these vectors. So if we can see this, the matrix is negative 4, 1, 1, 2, negative 3, 2, 3, 3, negative 2. And we're going to multiply this vector negative 2, 2, 0 by that matrix. If you multiply that, you get positive 8 here, positive 2, and 0. So positive 8 and positive 2 is 10. That's our first element. Negative 2 times negative 2 is negative 4. 2 times negative 3 is negative 6. And then 0 would give us negative 10. And then negative 2 times 3 is negative 6. 2 times 3 is positive 6 and 0. So it's negative 6, positive 6, and 0 is 0. So the question is this really just a numerical multiple of this vector? And so negative 2 would have to be multiplied by a negative 5 to get 10. And so that's a negative 5. And this also would be a negative 5. And this could be just about anything, of course. That's going to be a negative 5. So the answer to that is yes, it is. And the corresponding eigenvalue is negative 5. Because this is basically a times the vector x is equal to negative 5 times the vector x. So there's our eigenvalue. So that was an eigenvector and corresponding to lambda equal negative 5. Next, same matrix, and now we're multiplying by 2, 0, 1. And so we'll multiply negative 4 times 2 is negative 8, plus 0 plus 1, which would be negative 7, right? And then 2 times 2 is 4, then 0 and 2 would make 6. We can actually stop right there because 2 times whatever negative 3.5 would be 7, and that same 3.5 would not work. 0 times, you'd have to get a 0 there. So this is not an eigenvector. Already we can tell. If you want to do the last one, 2 times 3 is 6, and 0 and negative 2, that would be a 4 there. And again, you'd get a contradiction because you'd have to multiply 1 by 4 to get a 4, and clearly 2 is not being multiplied by 4, nor 0. So this is not an eigenvector. That is, this one is not an eigenvector, of course, for that matrix. Let's see about this one. Now, you get windshield wiper this. Negative 4 times 3 is negative 12, then 0, and negative 3, it looks like negative 15. Now, the next one we get 6 plus 0 plus negative 6, which is 0. So far, so good. 3 would be multiplied by negative 5. Let's see if this ends up to be negative 3 times a negative 5, which would be 15. What is this? 9 plus 0 plus 6 is 15. So indeed, if I multiplied this, isn't this a multiple of 3, 0, negative 3? The answer is yes. That is equal to negative 5 times 3, 0, negative 3. And so, again, the answer is yes, this is an eigenvector, and it corresponds with the eigenvalue lambda equals negative 5. Okay. So the next problem is something you should have an understanding of the idea behind this, but we haven't really done a problem like this, but I want you to be prepared for it because it's really a thinking problem. So think about this. If you're supposed to determine a matrix given the eigenvectors and other information. So there's an eigenvector and an eigenvalue. So if lambda equals 2 corresponds with the vector 1, 2, and lambda equals 3 with the corresponding eigenvector 1, 1. what do we know? What can we say about that original matrix that generates that? It would generate those two eigenvalues and those two eigenvectors. It's going to be a 2 by 2 matrix, clearly. So this matrix is unknown. Now remember, A times the vector 1, 2 is supposed to equal 2 times the vector 1, 2. That's what an eigenvector and value, corresponding eigenvector and eigenvalue would do. And this would give you A times the vector 1, 1 would equal negative 3 times the vector 1, 1. Which of course, this means that A times 1, 2 is equal to 2, 4. And this means A times 1, 1 is equal to negative 3, negative 3. Right? Well, what can we say? It says determine that matrix. So how do we find that matrix? Well, this is really like, let's just make up letters A, B, C, D. It's a 2 by 2 matrix times 1, 2 will equal to 4. Oops. And of course the same thing, A, B, C, D times the vector 1, 1 should equal the vector negative 3, negative 3. And so this gives us a system of equations, doesn't it? If we take this, AB times 1, 2 would be 1A plus 2B should equal 2, the first element. CD times the 1, 2 should be 1C plus 2D should equal 4, the second element. And similarly here we got AB times 1, 1. That's just going to be A plus B equals negative 3. And this C plus D equals negative 3. And now that gives us, notice that's 4 equations and 4 unknowns. But if we want to solve for A and B, there's 2 equations with the 2 same unknowns. If we use those 2 equations, put those together, and we have columns A, B, the matrix would be 1, 2, augmented would be the 2, and this would be 1, 1 augmented with negative 3. For C and D, we have the other matrix, and that would be 1, 2, augmented with the 4, and then 1, 1 with the negative 3. You could use your calculators to solve both of those if you wanted to. There's C and D. So this will give you the solutions for A and B, and this will give you C and D. This is so simple to row reduce this. If you just subtract row 1 from row 2, we'll get 1, 2, 2. This will be a 0. That'll be a negative 1, and that'll be a negative 5. And you could do more row reduction. Let's subtract 2 of row 2 from row 1. We get 1, 0. Add 2 of row 2 to row 1. 2 plus 2 of those. And 2 plus 2 of those, that's negative 10. That would make negative 8. So 0, negative 1, negative 5. And of course I can just make those positives. Okay, so this tells us that A would be equal to negative 8. B would be equal to 5. Similarly, we can subtract for C and D. We subtract row 1 from row 2, and we get 1, 2, 4, and 0, negative 1 again, just like we got before. And subtracting negative 4, that's negative 7. Of course, we can multiply that by a positive and make that 1 and 7. And now we subtract row 2 from row 1. We get 2 row 2 from row 1, sorry. 2 minus 2 of those would be 0. 4 minus 2 of those would be negative 10. We get 0, 1, 7. And so our C would be equal to negative 10, right? That's our C column and our D column. And D would be equal to 7. So the matrix A, B, C, D, A, negative 8, B, 5, C, negative 10, and D, 7. That would be the matrix that would generate those 2 eigenvalues with their corresponding eigenvectors.